Okay, Assalamualaikum. So today we proceed with the moment generating function for the continuous random variable. So before this, you have learned how to find the MGF for discrete random variable, right? So actually, kita akan gunakan the same concept, which is gunakan mathematical expectation. Okay, so as you know, untuk dapatkan MGF, we use a notation of mxd if our random variable is x. If the notation for the random variable is y, so it will be myt lah. Right, it is expected of e power of tx. If our random variable y, so it will be e power of ty. Okay, so this one dah belajar sebelum ni untuk discrete kan. Okay, for today kita nak fokus on continuous. Alright, so to find the expected of e power of tx, we need to multiply the function fx dengan expected of tx. Okay, barulah you kena integrate this multiplication of etx dengan fx with respect to dx. Okay, integrate terhadap x. Okay, integrate terhadap x after you multiply fx dengan etx. Integrate terhadap x from where to where? So kat sini dia letak from negative infinity to infinity. Actually it depends pada apa ni, interval for random variable x. Kan usually we know the interval for random variable x or y, so we use that interval here, okay, to put the value of negative infinity and infinity here. It depends pada interval for the random variables. Okay, so we go to the next example first. Ingat terus. Okay, untuk this continuous okay, let's say this is our function fx, expected of power of e exponential power of negative x. This is exponential function. Okay, dia punya interval adalah from 0 to infinity. Okay, x more than 0. So now kita nak cari mxt. Saya buat mxt because of our random variable denote as x. Okay, so it will be mxt. If here is y, so it will be myt. Okay, we use the concept expected of e power of tx. Okay, because of our x here, random variable adalah continuous, so we need to deal with the integration of e tx multiply dengan function e power of negative x. Integrate terhadap x. If the random variable denote as y, so kena integrate terhadap y lah. So here will be 0 to infinity because of the interval for random variable x is from 0 until infinity. Okay, so first thing first, we need to multiply the etx dengan a function e power of negative x. So apa akan jadi? Okay, so my advice is bila nak integrate exponent function kan, sebab exponent function ni dia punya interval adalah infinity, sehingga infinity. So my advice, bila you nak multiply the function, okay, nak multiply the function, nak gabungkan exponent dengan exponent ni, keluarkan negative x kat sini kan, so dia akan jadi kat sini kan, dia punya index ni kita boleh plus the index kan, so it will be tx plus negative x. Tapi my advice, keluarkan negative x sebab senang untuk kita integrate nanti. So dia akan jadi kat sini 1 minus t, betul tak? Okay, 1 minus t. Negative x, 1 minus t. Okay, and then next step, barulah integrate. Okay, multiply dulu the function, then baru integrate. So bila nak integrate the exponent function, so first you kena copy the function first, right? And then bahagi dengan we need to differentiate the index of exponent here, so it will be negative. Maksudnya kena differentiate terhadap x lah, so it will be negative 1 minus t. Kan, differentiate negative x ni, 1 minus t will be constant, so it will be negative 1 multiply dengan 1 minus t, 0 to infinity. Right, so saya sambung di sini, and then replacekan x with infinity, so you will get e power of negative infinity here. Kan, infinity multiply dengan apa constant pun akan dapat infinity, so saya letak kat sini e power of negative infinity divide dengan negative 1 minus t. Okay, minus dengan e power of negative 0. Kenapa saya letak 0 kat situ? Any value constant multiply dengan 0 akan dapat 0. So e negative 0 divide dengan negative 1 minus t. Okay, e power of negative infinity is 1. Right? E power of negative infinity is 0. Okay, 0 here, and then will be plus, negative no negative, so it will be plus e power of negative 0 is 1 divide dengan 1 minus t. Alright, so dekat sini you akan dapat the so finally the MGF ataupun MXT for random variable x adalah 1 over 1 minus t, ataupun we can write it as 1 minus t power of negative 1. Okay, so kenapa saya suggestkan tadi here dekat sini saya suggestkan untuk keluarkan negative x because of di sinilah tadi, sebab bila dah integrate kan, dan then replace x dengan infinity, we know that e power of negative infinity is 0. Okay, kalau you tak keluarkan negatif dekat sini, so dia akan jadi e power of x kan, e power of infinity, dia akan jadi infinity, so dia akan complicated sikit bila nak nak selesaikan di sini. So saya suggestkan you keluarkan negatif di sini. Alright, so kita solve that. So our final answer kat sini adalah this one. Okay, alright, so that is the way how you find the MGF for continuous function, or for continuous random variable. Okay, so it depends lah pada function complicated ataupun tidak. Kalau function you bukannya function exponential, tak ada masalah kan, senang je nak dapatkan, nak integrate that function. So kalau melibatkan exponential, you should do like this. Okay, try buat another one despite from past year question actually. Okay, so let's do this. Okay, notation for MGF. If MXT, I use x here because of we denote x as the random variable. So it is as factor of e power of the x So it will be, because of x adalah a continuous random variable, so to find the MGF, we need to do the integration of the e power of dx multiply the function. Function is 3x e power of negative 2x integrate terhadap dx. Integrate from 0 to infinity because of x more than 0. Okay, so multiply the function first. Okay, because of 3 here, I put in front because of 3 adalah constant. Then multiply exponent function here, x e power of negative x. Keluarkan x because of it is exponent, and then kita nak integrate. The interval is infinity nanti, replace x dengan infinity. Because of that, kita keluarkan negative x here bila you nak fakturkan the index of the function. Negative x 2 minus t, kan? Okay, dx. Alright, so from here what we need to do is macam mana nak integrate the function x multiply e power of negative x multiply 2 minus t dx. Okay, kena buat integration by part. Remember, integration by part, first kena determine dulu u. We let u is x and v, and integration of v. Okay, and v adalah integration of e power of negative x 2 minus t dx. Okay, so here du over dx equal to 1, so du equal to dx so v will be e negative x 2 minus t. Okay, integrate, so kena divide dengan differentiation of the index will be negative 2 minus t. Okay, so this part, okay, so apa yang kita nak buat kat sini adalah 3 uv minus integration of v du. Kan, so takkan u as x, v adalah e negative x 2 minus t divide dengan negative 2 minus t here. Okay, uv, this part uv minus dengan integration of v du. Okay, integratekan v, this part tu. So I buat plus kat sini sebab di sini minus kan. So minus dengan integration of v, so e negative x 2 minus t divide dengan 2 minus t kat sini terhadap du. Du equal to dx kat sini, so kita letak kat sini dx. Okay, that part. Kat sini jadi plus sebab di sini negatif ni, kan? Dan minus kan integration of v. This part. Okay. So kita selesaikan dulu integration here. So salin balik yang ni. Actually this part akan dapat 0 lah kan. Divide dengan negative 2 minus t. Okay, plus. Okay, so integrate this part. So it will be kalau nak keluarkan 2 minus t ni pun boleh sebab 2 minus t ni akan jadi constant lah kan. So kita keluarkan dia pun boleh, 1 minus 2t this part, then integrate that part. So negative e power of negative x 2 minus t, bila integrate dia akan jadi negatif lagi sekali kat sini, negatif 2 minus t kan terhadap x tadi tu. So this part. Okay, so tertinggal tadi sini kat sini 0 infinity because of this part kan, 0 infinity. So replace all of this thing dengan 0 dengan infinity. So saya selesaikan kat dalam ni dulu. Okay, this part, yang this part ni kan, dia akan jadi, tak apa, kita salin je dulu. Divide dengan negatif 2 minus t. So yang ni dia boleh jadi one divide 2t, dia buat square macam tu, keluarkan dia kan. So this part dia negatif e negatif x 2 minus t. Okay, alright, so kita finish this, selesaikan. Okay, e power of negative infinity, first thing first, kita replacekan all the x with infinity. So this part, e power of negative infinity is 0. So it will be 0 here. Okay, minus dengan, this part, kita selesaikan this part first. Minus dengan bila you replace x with 0, you akan dapat 0 kat this part, right? Okay, plus dengan 1 minus 1 over 2 minus t square. Okay, write this part. Negative e power of negative infinity is 0. So this part is 0. Negative 0 minus dengan replace pula dengan 0. It will be e power of negative 0 is 1. So that part will be 1. Right? Is it true? Oh sorry, kat sini silap sikit. So kita dah keluarkan negatif, sini will be 1 lah kan, positif. Right? So it will be, this part will be 1. So it will be 1 over 2 minus t square. Ataupun we can write it as 3 multiply 2 minus t power of negative 2. Okay, is it 2? 3. Okay, so samalah dengan that part tadi. So this is the proving of the MGF for this function. Okay, so it depends whether the integration, whether to find the moment generating function for the certain function of continuous is complicated or not, depends pada function tu sendiri. Okay, so kita gunakan konsep yang sama je sebenarnya, mathematical expectation, which is expected of e power of tx. Okay, multiply dulu dengan function, then integrate. Okay, so it depends whether it is complicated or not to find the MGF adalah that function itself. Alright, okay. So macam sebelum ni, apa kita boleh guna, we can use the MGF to find the mean and the variance. Konsep yang sama macam sebelum ni, which is bila we differentiate, okay, to get the derivative once, okay, then replace t with 0, kita akan dapat mean. Okay, differentiatekan moment generating function once, sekali, replacekan t with 0, so akan dapat mu ataupun mean, which mean here lah. Okay, replace t with 0. Okay, untuk dapatkan variance pula, as factor of x square minus dengan mean square, which is this part, m double prime tu adalah bila we need to find the second derivative for the MGF, then replace it with 0, you akan dapat x factor of x square. Okay, minus dengan mean, then squarekan mean. Okay, so how to get the mean? This part. Okay, untuk dapatkan variance, we use the familiar formula that we know already. Okay, so we can find the moment generating function. We can find the moment we can find the mean and the variance using the moment generating function as usual. Okay. Okay. So that's it. Let's say lah kan, macam tadi. Let's say lah. Kita ada ni. Let's say this. MGF, dah ada MGF ni, kita bolehlah cari mean dan variance for this random variable x. Actually nak cari mean, kalau kita ada dua cara lah, sama ada macam sebelum ni. Nak cari mean kan, you boleh gunakan we use this concept as factor of x, so kena integrate kan x multiply the function kan terhadap dx, so maksudnya kena integrate, kena multiply dulu x dengan 3x e negative 2x dx from 0 to infinity. So apa kena buat kat sini ni, kena buat, dia akan jadi macam 3x square e negative 2x. Okay, so kena buat apa? Kena buat integration by factor, kena buat substitution kan untuk dapatkan x factor of x. Satu lagi cara, kita boleh gunakan MGF untuk dapatkan mean. Okay, bila once we have the MGF function, kita bolehlah gunakan the MGF untuk dapatkan mean. Okay, another alternative lah kan. So saya tunjuk cara, actually yang ni pun you dah biasa buat, macam gunakan konsep macam sebelum ni lah kan. So just saya tunjukkan another example here. Okay, let's say kita nak dapatkan mean from MGF using MGF. Okay, so we need to find the derivative of the MGF once, then replace all the t with 0. So first thing first, kena differentiatekan MGF, this MGF, with respect to t. Okay, with respect to t. So apa akan jadi kat sini? 3. Okay, the index tadi kena multiply dengan kat depan kan. And then copy balik that part. Okay, index dia bila differentiate, so it will be negative 3. And then kena multiply pula dengan derivative dalam function 2 minus t tadi. Akan dapat negative 1 kan. Okay, differentiate terhadap t, then replacekan t with 0. So you akan dapat dekat sini 6 kan, 6 2 minus t power of negative 3. So you akan dapat the value will be bila replacekan t with 0, so you akan dapat 6 multiply dengan 2 power of negative 3. Apa dapat? 6 over 8. Right? Yeah. 3 over 4. Okay, mean for random variable x. Okay, untuk dapatkan variance, first kena cari dulu as factor of x square, which is we need to find the second derivative of the MGF, then replacekan t with 0. Kan? Okay, so differentiate kan this function tadi, this part, differentiate this part. Sebab ni kita dah differentiate once, so differentiate lagi sekali maksudnya kita dah differentiatekan this function with respect to t. So you akan dapat 6 negative 3 2 minus t power of negative 4 multiply dengan negative 1. So you akan dapat 18 2 minus t power of negative 4. So it will be 18 over 16. Right? So the variance will be 18 over 16 minus 3 over 4 square. So it will be 18 over 16 minus 9 over 16. So the answer will be 9 over 16. Okay, so this is the variance. So this is the way how to find the variance using the MGF function.